Okay, today we will be talking about the interpolation. So first is what is interpolation? So interpolation, when we say interpolation, we uh, mathematically estimate datas or numbers in a certain range of datas to create new known data. For example, we have this particular set of data. So for example, uh, we have time zero. For example, we have 580 units, and maybe at time 104, we have around 3,722,57 units. And we want to find the data in between these two given points. So for example, at this given point, we want to find the data at t 79. So at 79. So what will be its corresponding number of population? Let's say ito yung ating population per time. So how do we do that? So we use interpolation. So in doing interpolation of that, let's move in. First is we need to make a table. So to separate our data. So let's say our time is X and population is Y. So we are given a particular set of data that at time 0, we have 580. And at time 104, we have around 3,722,57 units of population. And as we say, we want to find what's in between of these two, which is at time 79, or let's say day 79. So we need to find, so let's assume that the population at day 79 is Y. So in interpolating, first is we need to subtract the upper limit or the upper value and the middle value of both sides. So upper value of the both sides, so that is 0 minus 79, then equals to 580 minus Y. Then divide each by the upper, subtracting the lower limit. So that will be 0 minus 104 all over that is 580. 580 minus 3,722,57. So now we have created an equation. So since we are finding y, let's find y. So we can cross multiply both sides. So 0 minus 79, that is negative 79. That is negative 79 multiplied by 580 minus 3,722,57. That is negative 3,721,477 equals to negative 104 multiplied by 580 minus y. So let's simplify it further. So negative 79 times negative 3,721,477. So that will be 2 million, or rather 293,996,683 equals to the simplifying these two. So distributing 104, that will be positive 104y minus 60,320. Okay, simplifying, we have 104, y will be equals to 293,996,683 plus 60,320. So dividing both sides by 104, so we will get y is equals to 2,827,471.183. So that is how you interpolate. Another application of interpolation is on temperature calculations. In temperature calculations, let me give you an example to prove. We all know that the freezing point of water in degrees centigrade, so the freezing point in degrees centigrade is 0 degrees centigrade. Whilst in degree Fahrenheit, that is 32 degree Fahrenheit. While the boiling point of water in degree centigrade is 100 degrees centigrade. Okay? And the boiling point at degree Fahrenheit is 212 degree Fahrenheit. Let's make a table. So this is the degree Celsius, and this is the degree Fahrenheit. So we have here the boiling point of the freezing point rather of 0 degrees and 100 degrees. And on the other side, the freezing point of 32 degrees Fahrenheit and the boiling point of 212 degrees Fahrenheit. So for example, we want to find degree C temperature at a certain degree F temperature. So we use interpolation to this. So interpolating the values, so that will be 0 minus C all over 0 minus 100 is equals to 32 minus F all over 32 minus 212. So 0 minus C, that is multiplied by 32 minus 212, that will be 32 minus 212, that is negative 180. So negative C times negative 180 is equals to negative 100 times 32 minus F. So we will have here 180. C is equals to 100 F minus 3,200. So we are finding the value for the degree centigrade or C. So let's divide both sides by 180. So cancelling, we will have C on this side. Then maybe we could factor this equation out. So factoring out, we can have 100 times F minus 32 divided by 180. So simplifying 100 over 180. So this bit here, these two values, they can be divided both by 20. So dividing both by 20, 100 divided by 20, we will have 5, and 180 divided by 20 is 9, multiplied by F minus 32. So there we have it. If this equation looks familiar to you, then we have proven that interpolation is used to convert temperature. So for the degree Fahrenheit, I leave it to you for the computation.